Another detailed super restoration. Restoration Master, Restofix. Today we're fixing ... This completely total ... 2000 Sega Hello Kitty Limited Edition Dreamcast console. As you can see from the start, the disc cover won't stay shut. Once the cover is opened, you can clearly see the power module. There are obvious burn marks here. Also, according to the owner, a few days before it died completely, it had screen flickering issues. But as for the exact cause or other issues, we'll have to take it all apart ... and inspect it to find out. This broken latch is likely why the disc cover won't stay closed. This Dreamcast, as Sega's ... all-out effort in console design, has many highlights. But we'll get to those later, because now the master has finished the initial tear down. Moving on to the repair, the first thing to fix is this charred power module. To better identify the problem, he'll first remove the larger components. Well, see, here is a capacitor here that's completely burnt out. From this angle, the burnt site is right between the large capacitor and the transformer. This isn't just any circuit, it's the high voltage switching core. Normally, it converts rectified high voltage DC into high speed pulses for the transformer to step down. But if a capacitor ages or gets damp, or a switching component shorts, the current goes out of control instantly, causing it to burn out. After a quick analysis, he'll use some multi-purpose cleaning foam, trisodium phosphate, PCB cleaner, and isopropyl alcohol are used to deep clean this board. Trisodium phosphate, or TSP, is highly alkaline. It breaks down carbonized oil and soot. This is how it looks after deep cleaning. What do you think? Also, these removed voltage regulators, high-frequency transformers, and EMI filters will get the same deep cleaning. Next, per the schematics, the master replaces the scorched parts with brand new ones. Of course, the parts removed earlier for separate cleaning will all be reinstalled. Once everything is soldered, I'll turn on the power to check the output voltages and see if they meet specs. Besides the power module, the master also deep cleaned and tested the power switch cable. The results? They're all back to normal. The cooling fan, after cleaning, is also back to top shape. Next up is this I/O control board. First, use a heat gun unsoldering iron to remove the cover and button battery. This soldered-in button battery is a Sanyo 20/30, not the common 2032. For future convenience, the master will install a standard battery holder. Besides regular cleaning, a grinding wheel is used to polish the socket pins. Seeing this reminds me of my childhood. A guy told me, if the computer keeps freezing, pull out the RAM and rub the gold fingers with an eraser. It's an old school trick, but it actually works sometimes. Now, with the cleaning done, we also need to check the capacitors and do a functional test. Once confirmed working, install the new battery socket, cables, and the original cover. The I/O board is now finished. Next is the optical drive for a deep clean. It must be fully disassembled. This drive is missing the lens cover and top panel. As a core component, it has some highlights compared to standard CDs. This drive uses GD-ROMs, which look like CDs. The best part of GD-ROMs is the higher data density, storing more game data. These discs have inner and outer rings. The inner ring is CD compatible for audio and boot data. The high-density outer ring stores the game data, unreadable by standard devices. This special format helps prevent game piracy. Besides disassembly, he also removes the original stickers to save them. When finished, he'll put them back. I must say, that's very meticulous. Now he's working on the spindle motor. It's responsible for spinning the disc. After cleaning, the rotor needs some fresh grease. The laser motor gets the same treatment. Next is the core laser lens assembly. You can see the ribbon cable is broken. Besides the cable, this component also has a focusing lens for the laser, a laser diode to generate the beam, a photodetector for reflected signals, and a drive coil for focus. As for how this works, it's actually quite simple. The laser from the head scans the microscopic pits on the disc. Then the reflected laser becomes an electrical signal. Finally, after decoding, you get the data. The glue holding the lens has aged, so he'll use epoxy to secure it again. Also, as mentioned, this laser assembly was missing its cover, so he 3D printed a new one. Now install the lead screw and the laser unit is ready. Next is the drive's control board. This board controls the motor and laser and processes the signals. So if the motor is the muscle and the laser is this board is the brain. After cleaning it with slime, the board needs a full inspection. It seems mostly fine. This capacitor still works, but it's showing signs of age. To prevent future issues, it will be replaced. Also, the connection holes between the board and shield need resoldering. Besides heat dissipation, their main function is grounding. If the ground is unstable, all signals will lose reference, becoming unpredictable. Next, I need to handle this optical drive chassis plate. To deal with the rust, I'll use this rust removal gel for chemical de-rusting. After letting it sit for 2 hours, it can be washed with the other parts. After cleaning, I'll spray the plate with silver anti-rust paint. With that, all the optical drive parts are ready. Now I can reassemble it. As mentioned before, this Sega console uses custom GD-ROMs. They share the CD form factor, but have higher capacity. Plus, standard devices can't read them. It seemed like a very clever anti-piracy solution. But the problem was, the Dreamcast also supports MIL CDs. This multimedia format boots programs from standard CDs. It was meant to add features, allowing the console to play games, while also running interactive content and multimedia. But people soon found that with a special CD structure, disguising the start as audio before the game data, you could use the MIL CD feature to run burned games directly. This meant no soft mods, or hardware hacks were needed. Just a standard burner was enough to play anything. In theory, this exploit could be fixed, but it wasn't in the games. It was in the console's boot logic, for the units already sold. Back then, it was nearly impossible to update or fix. Later, Sega tried, in newer console versions, to disable this feature entirely. But by then, tons of old units were already on the market. Piracy was already rampant. In other words, even if you close the door, by this point, everyone is already inside. And this issue was a major reason why the Dreamcast only had a lifespan of about 2 years. Back to the VIKY. The Pro uses conductive silver paste and a patch to repair this damaged original ribbon cable. This missing optical drive top panel is an original used part found online. Finally, after sticking this plastic piece on, the optical drive is finished. Next, the motherboard. As before, cleaning slime is used first to remove most of the dust and dirt. This huge chip here is the console's GPU, the graphics processing unit, designed by Videologic in the UK. The model is the PowerVerta CLX2. This smaller one next to it is the SH negative for CPU, developed by Hitachi in Japan. For the full specs, refer to the image above. After the initial cleaning, the next step is deep cleaning and a full inspection. After testing, the motherboard is fine, but as mentioned earlier, this unit has a flickering issue. So if the flickering persists, all components in this red area will need to be replaced. Of course, we'll only know after testing. Next up is the console's casing. Same as usual, start with a deep clean. Remove all the dust and dirt, and any leftover glue residue. As for these yellowed marks, the best way to handle them is the retrobrighting method. Soak the yellowed plastic in hydrogen peroxide, then use UV lights for long-term exposure. This way, the hydrogen peroxide produces highly active hydroxyl radicals to attack and break down the structures, causing the yellowing, restoring its original white look. What about these to-back labels? He tried making them himself, but the results weren't great, so he got these 2 original used ones. The last thing to handle is this transparent shell part. As for the cleaning process, we'll skip that and go straight to fixing the broken part, preventing the lid from closing. A clip broke off here. Just using glue isn't very strong, so he'll add a reinforcement inside. One doesn't seem enough, so he's adding 2. Once the glue is dry, he can take the clean transparent shell and reassemble it. In the meantime, let's look at a highlight of this machine. Its GPU architecture. Standard 3D rendering usually draws everything in the scene first, then decides what's hidden and what's visible. Drawing everything wastes a lot of performance. The Dreamcast's approach is, first, divide the screen into small tiles, then determine which tiles will actually appear on screen. Only those visible parts are rendered. This is tile-based deferred rendering. No effort is wasted rendering things you can't see, saving a lot of performance. So the graphics on this console feel incredibly sharp, with clear textures and clean colors. It doesn't blur easily, even at low res. And all this is achieved with its small VRAM and limited computing power. It's not a brute force GPU, but a very smart one. So why did it fail? besides the piracy issues mentioned. T here is the usual game library issue. Due to its unique architecture, it wasn't backward compatible. But the biggest reason, I think, is because it faced the star of that era, Sony's PS2. Finally, put on the clear shell. And this Hello Kitty Limited Edition Sega Dreamcast console is officially restored. By the way, this console was the first to make online play a core feature. Just plug in this modular modem to get online. Its controller is also interesting. You can insert a standalone gaming and memory card mini device, the VMU. As for the keyboard, it's because you can browse the web on it. You can open web pages, send emails, and even chat. With all the gear ready, let's move to the final demo. The demo was a success. Finally, let's look back at how it looked before. That's it for this restoration. Thanks for watching. Time flies when you are having fun. It's time to say goodbye. Thanks again for visiting Max's Restoration. Bye bye.